Hello, dear participants. First of all, thank you for choosing to listen to my presentation titled Robust Regression Estimation based on the Exponential Power Series Distribution. I am Dr. Mutlu ALTUNTAŞ. I am attending this conference from Sinop University Statistical Department. We carried out this study together with Professor Dr. Olcay Arslan from Ankara University Statistical Department. And firstly, I will talk about purpose of this work, and then I will introduce you exponential power series EPS distribution, and I will present robust regression modeling based on EPS distribution, and that will be followed to real data application, and finally I will give you some conclusions. Creating a robust regression estimation procedure is an important process due to providing the purchase from the original regression modeling assumptions or conservation from data which contains the outliers. The concept of robustness is a desirable property of statistical estimators to make reliable inferences from data without being excessively affected by these departures. And when data set includes few or many outliers, inference depends on the error distribution with a long tail in the classical linear regression model. This case causes a large deviation from the assumed normal model. And in the sense, robustness to long tails is crucial, and it can be obtained by specifying the sampling model from within some robust distributions, which is enriched with robustness parameters. And in regression modeling, one way to obtain robust regression estimation parameter estimation is to utilize regression models with have-a-tail distributed errors. And in this regard, exponential power series distribution happens to be candidate have-a-tailed error distribution. And the use of EPS distribution is considered here for the reason that its potential on the robust regression estimation has been largely overlooked in the literature. The main goal of this study is to show how to obtain a robust parameter estimation of estimation using regression modeling based EPS error distribution compared to distributions such as Studenti and Laplace. And exponential power series distribution is introduced by Fox and Tiao. And if X random variable has EPS distribution with these parameters, the density function of X random variable is given by like this. In this density function, C delta and K delta are constants, depend on the delta parameter. And in EPS distribution, mu is the location parameter, sigma is the scale parameter, delta is a non-normality parameter. Special cases for this distribution are like this. If delta is equal to 0 normal, if delta is equal to 1 double exponential, and if delta is equal to -1 rectangular distribution. For delta is greater than 0, the distributions have heavier tails. For delta is less than 0, the distributions have flatter tails than the normal. And as you can see from this plot, if delta parameters equal to 0, the normal distribution, color of it is red. If delta parameter is equal to 1, the double exponential distribution, the color of it is purple. And if delta parameter is equal to -1, is the rectangular distribution. The color of this distribution is yellow. And distributions with different tail thickness for the cases of delta is greater than the 0 and delta is less than the 0. And if delta approaches to 0, distribution is similar to normal. And the color of it is red. And if delta approaches to 1, and distributions have heavier tails than the normal form, and this is similar to double exponential form. The color of it is purple. And if delta approaches to -1, and distributions have flatter tails than the normal, and this is similar to rectangular form, and the color of it is green. And we consider this multiple linear regression model in the study. And if the random error has a EPS distribution with these parameters, and the density function of the random errors and is like this, and delta parameter is considered as fixed. And for regression model parameters, likelihood function and log likelihood function is like this. And when the log likelihood function with respect to beta and is the derivative, when the log likelihood function is derivative with respect to beta, robust estimator of beta is obtained like this. And in this equation, Wi EPS and is the estimate of weight function for likelihood. Similarly, when the log likelihood function is derived with respect to sigma parameter, and the robust estimator of sigma is obtained like this. And for real data application, we consider two real data sets, and data 1 gives the international number of calls made from Belgium in terms of the years. And for this data set, we present two simple linear regression model. And firstly, least CQR model, which is obtained according to assumption of normality. And secondly, Huberan model, which is obtained with respect to M robust regression method. As you can see from this plot, from both models, there are six outliers in this data set, and we assume that the error distribution have normal and student Laplace and EPS distribution with these parameters. And when the parameter estimates of the regression models based on the different error distributions are examined, it can be said that this data set can be modeled robust regression based on the EPS distribution with the lowest AIC value. And another data set we considered state loss data, and for this data set we used multiple linear regression model with 3 predictors. And for state loss data set we present 2 multiple linear regression model. Firstly, least CQR model, which is obtained according to assumption of normality, And secondly, Huber model, which is obtained according to M-robust regression methods. And as you can see from both models, there are 3 and 1. There are 4 outliers in Steklos data set. And when table 2 is examined, it can be said that the robust regression model based on the EPS error distribution and with the lowest AIC value may be preferred in modeling of a Steklos data set. And in the study, we considered robust parameter estimation of a regression model with EPS distributed error. And in real data application results shows that the robust regression estimation based on the EPS distribution with the lowest EIC value, and robustness of EPS is better than the selected student T and Laplace have-tailed distributions. Thank you for listening.